Okay, let's evaluate the given integral by changing it to polar coordinates. So we have a double integral over our region D, e to the negative x squared minus y squared dA, where D is the region bounded by the semicircle x is equal to the square root of 36 minus y squared and the y-axis. So obviously we have x is equal to 36 minus y squared, and something that I want to do, it's quite tempting, is just to square both sides. So you get x squared is 36 minus y squared, and then add y squared to both sides. We have x squared plus y squared is 36. Very nice. It's just a circle. However, your x has to be positive. X is greater than 0, greater than or equal to 0. It has to be. So since x is greater than or, so this is basically the this is basically the constraint that you have when you solve. So this is what you have, but x has to be greater than or equal to 0. That's basically what it says when you rewrite it in this form. This form actually just implies it, because square root 36 minus y squared can be 0, but it cannot be negative. It can be positive and 0. And so basically this is equivalent to that. If we graph it, we will end up getting x, y. X has to be positive, so it's going to be the semicircle in this region of our graph, so in quadrant 1 and 4. So 6, let's just say this is 6. This is 6, negative 6. And so if this is 6, our graph is basically going through these 3 points, like so. That's okay. It's an okay drawing. This is your circle right here. X is positive. This is your circle, and it's basically our region now. We gotta focus on our region is bounded by this and the y-axis. The y-axis is this axis here. So that clearly gives that our region is that region right there. Now obviously it's like a circular region, so polar is a great option. So polar, let's specify our theta. Theta goes from 0. Oh, sorry, no, that's not what I wanted to say. 0 is here. 0 is here, but it's not going from 0 to something. It's going from negative pi over 2 to positive pi over 2. That's what I like to do when we have this kind of situation. Your lower bound has to be smaller than your upper bound, and the way you can do that is just go from negative pi over 2 to positive pi over 2. It's basically this entire region. And then r goes from, you can use a similar method to what I used in example 3 of this video series. Start at the origin, and do you immediately enter your region in any direction? Yes, you do. So that means r starts from being 0, and then when do you almost exit the region? So the boundary, the end of the region, is when r equals to 6. And that is the boundary. That's r equals to 6. So 0 to 6. And then what I'd like to do is I just like to rewrite, so it's negative e to the negative x squared minus y squared. So just rewrite it, doesn't matter for now. And then add your r, dr, d theta. Don't forget the r. It's very important. It's called a Jacobian. It's very important. Now we have to convert everything to r and theta. So in terms of r and theta, the only things we have is negative x squared minus y squared. We want to convert this. Let's factor out a negative 1 to make this x squared plus y squared. And now you see why I did that. Because we can convert x squared plus y squared to r squared. If you don't know this conversion, you cannot get a lot of these problems correct. You will suffer. So you have to know these conversions. This is just negative r squared. So this is e to the negative r squared. r dr d theta. And that's pretty much the setup. This is the most important part. So you can take this problem on from here, but I will solve it. So let's solve it. You can split this up into 2. You can split this up into negative pi over 2 to pi over 2 of 1 d theta multiplied by 0 to 6 e to the negative r squared times r dr d theta. Sorry, not dr d theta, dr. Just dr. This is equal to, so it's theta evaluated from negative pi over 2 to positive pi over 2 multiplied by, now we can use the u sub here, so u is equal to negative r squared, so du is equal to negative 2r dr. So we have to insert a negative 2 in, so we have to insert a negative 1/2 out. So negative 1/2 and then negative 2r dr becomes du and then e to the u. And then 0 to 6, so we just have 0 down here, and then 6 will become negative 36, because 6 squared is 36, and then negative. You might be thinking, how does this make sense? You know, the bottom one is greater than the top bound. It does make sense because we can switch these two and make this negative into a positive. That's something that you need to know about integration. Theta from negative pi over 2 to pi over 2. And then we have multiplication 1/2, I made it positive, and then lower bound is negative 36, upper bound is 0, e to the u du. And what I should have done is, and I'll do it right now so we can save some space, this is just going to be e to the u from negative 36 to 0. It's the same thing, because the integral of e to the u, derivative of e to the u, same thing, it's just e to the u. So let's continue. Let's continue this up here. So this goes from pi over 2 minus negative pi over 2, so it's positive pi over 2. And then multiplication 1/2 times e to the 0 is 1, and then e to the negative 36, so it's minus e to the negative 36, 1 over e to the 36. So this is pi over 2 times 2, which is just pi, and then times 1/2 1 minus 1 over e to the 36. This is not too hard now, it's just pi over 2 times 1 minus 1 over e to the 36. Honestly, I would leave it here. You could distribute if you want, making pi over 2 minus pi over 2 e to the 36, but it's the same thing, and I think this one looks a little bit neater. So that's your volume over the region here under your function.